So again, anything that repeats itself, like in engines or tires that go around, seasons repeat themselves, tides repeat themselves. Anything that repeats itself over a regular interval can be modeled by a sine or a cosine graph. So how do we do that? Well, we need to know what a maximum is and what a minimum is, and then we can find the amplitude, the center line, the period, and write the equation from there. So, starting off here, we're looking at tides. Bay of Fundy has the biggest tides in the world. At the dock in the bay, a maximum depth of 8 meters is measured at 4:30 a.m. So if we were starting to graph this, and we put depth here and time here, how would you write 4:30? Because I don't think you can type 4:30 into your calculator. There's no place for the 2 dots for your calculator. What would you put instead of 4:30 if you were typing something into your calculator? 4.5. So I'm going to put 4.5, I don't know, let's say right there, 4.5. And then it has a maximum depth at 8 meters. So I'm going to put 8, and I'm going to draw a dot right there. At 10:42, this is harder than 4.5. 10:42, you're going to write 10 point something. But you're not going to write 10.42. Because if 4:30 is 4.5, 10:42 should be more than 10.5. How do you figure out what decimal you would write for 10:42? 4.2. Okay. How did you figure out 0.7? You're right, it is 0.7. What did you do? 42 out of 60. Can you see that 30 out of 60 was easy for you to do mental math? Your brain went no problem, 0.5. 42 out of 60, not as easy mental math, although not too bad, because if you divide both of them by 6, you get 7 out of 10. That's not too hard to change to a decimal. But you can also maybe check it with the calculator to make sure. So then we have 10.7, and at 10.7, it's at its minimum of 2 meters. And this is the only information we're given. Now we know it's periodic, so it's going to do this. Okay? Can you tell me the center line? Because we have to undab C this if we want to create an equation. If you know the maximum and you know the minimum, does it make sense that the center line has to be right in between them? And if this distance is 6, then the distance from the top to the center line has to be 3. And if you check, is 5 right in between 2 and 8? Yes. You could also do an average, right? If you want to find the middle of something, 2 plus 8 is 10, divided by 2, you get 5. So now, if we're thinking about dab C, we've already figured out the D value has to be 5. We've also, by doing that, we also figured out the amplitude while we did that. The amplitude is the distance from the middle to the maximum. Not quite, from the middle to the maximum.
Yes,
3. Now the period is how long it takes to repeat itself. And the way that we've drawn it right now, it's not repeating itself yet. It repeats itself once it gets to the same point again. So if you started with this maximum, we really would have to figure out, when is it back at that maximum? Because if you could go from here to here is 6.2, right? So again, if you did that again, from there to there, it'd be another 6.2. I could label this at 16.9, which would be, right, almost 5 o'clock. And so your period is 12.4, because this would be another 6.2. So it takes 12.4 hours to get from one maximum to another maximum. And taking that into consideration, you have a formula that your b value is 2 pi over your period. So you could write your b value as just 2 pi divided by 12.4. Now, normally when we have a period, we separate things into 4 equal sections. Does it make sense if this distance is 6.2, that half of that would be 3.1, so I could add to get 7.6 there, add 3.1 to get 13.8 there. You could even work backwards. Can you see that you could work backwards here? Minus 3.1, this would be 1.4 right there. Now the first question in this example says, write 2 equations, one for sine and one for cosine. So if I'm writing an equation for sine, my a value is 3. My b value is 2 pi over 12.4. I'm going to leave out my c value because my d value is plus 5. This is going to be true for your sine graph or your cosine graph. So I can already, if I want to start my cosine graph, cos, the b value is the same, leave some space, my d value is the same. The dab part is the same, whether you have a sine graph or a cosine graph. To find the c value depends on the starting point. Where does a sine graph start? I'll do this one in purple. Sine graph starts in the middle, going up. So you could use this point right here, in the middle going up. Or you could use this point right here, in the middle going up. Both would be right. How do we do that? Well, each of them have been shifted to the right. How do you show a shift to the right? You do minus. If you use the 1.4, you'd write 1.4. If you use the 13.8, you'd write minus 13.8. And both would be right. Right? If you want to be mean to me, you could figure one out that happens 7 kilometers that way, and then write it down. And then you force me to have to check to make sure you were right, because you could add another 12.4, another 12.4. So you could say, ooh, I'm going to add 12.4 79 times, and figure out where that would be, and write that down. Then I might just mark it wrong, and you'd have to argue that it was right. That would be the least amount of work for me to do, right? That's not a very good teaching strategy. No, let's just do that. There, here's your test back. 0. Well, better start arguing. Oh, no, that wouldn't be very good. Because then my whole lunch hour would be a lineup of people that are very happy, right? You guys like it when teachers make mistakes, right? Take away marks that you deserve. Okay, and let's do the cos graph in green. So cos graph starts at a maximum. Well, I have a maximum right here, or I could use this one. But usually people like to use the one that's closest. So 4.5 to the right, so I would write minus 4.5. And so a lot of this unit, as far as word problems go, is about, can you draw the picture and write the equation? Then if you have the equation, right, they have some extra questions. Estimate the depth at 130. Now it says estimate, so you could go to your graph and just do the best that you can without figuring out exactly. At 130, that's at 13.5. If I go up and over, I might estimate it to be 3 meters. This is truly an estimate, because I just hope my graph was drawn nicely. If you wanted to find it exactly, 13.5 for x. And it wouldn't be hard. You could take out your calculator. We use one of these equations. So I'm going to use the cos one because I can't see the other one. 3 cos. So fast. 2 pi, oops, 2 pi divided by 12.4 bracket 13.5 minus 4.5 bracket plus 5. So we can see how close was our estimate of 3. If things are really off, then we'll have to decide, did we type something into our calculator wrong, or did we estimate wrong? 4.54. Okay? Technically, that's not too far off my estimate. I guess if we think about it, isn't 13.5 pretty close to 13.8? I should have maybe done my estimate closer here. And then it might have been more accurate, straight across. Okay? So the graph, the more accurate you are with your graph, the better. Okay, I ordered pizza for the tournament. Hello? Okay, if you want to come in and bring it to the office, I'll meet you down there. It's just, if you come in the main doors, it's just turn to the right. Yeah, bye. Okay, pizza's here. So, I will hand out for you. I have a take-home quiz for you.
We don't want it.
You have to get it anyways.
Why?
Because it will be an assignment no matter what. So, you can pass them out. And then, volleyball players, you guys can grab one of these and then you can go. I'll go pay for pizza.
When it like starts. Oh, okay.
To her? Yeah. Don't look at her right now, look at her right now. I got all my life on it, bro.
I think I have it on, but I have it on.
Hey, look at her right now. Good boy. Look at the boy, look at the boy. No, let's wait for the bell, bro. Let's go. Hold on. What time was that? No. Wait for the time. Wait for the walk.
You know, are you down for reading?
You see, you put in the mailbox. Easiest place to find. Yes. So if you have $2, it's $2 a slice for during the volleyball game. Okay, so if you want to go down to the gym, you can. If you don't want to go down to the gym, you can stay in here and work.
Yeah, can we go now?
You can go now.
Can we go like, can go now? It's an excuse to. There's like half an hour.
Oh, and I was recording the whole time.
Hey, let's go.